as we speak about generative AI for the enterprises. I want to start by laying the foundations for how we see that, that technology affecting the enterprises and the landscape overall today. The market size for such technology is around $10 billion today and expecting to be tenfolds within 2030, so around $100 billion by 2030. The productivity gains that are promised from this technology are in the vicinity of 20, 30, and sometimes 40%, depending on the applications. And the economic impact from such technology is also in the vicinity of $3 to $4 trillion annually by 2030. So huge potential, huge hype that is happening at the moment. However, when you look into the organizational readiness today, there's a big challenge in implementing this technology at scale beyond proof of concepts to realize those benefits, specifically on productivity, but also to realize the market impact and the economic impact afterwards. From our research, we see that we take a 10-20-70 rule, saying that 10% of the focus of organizations should be on data, 20% should be on algorithms, and 70% should be on people and process. So a lot to make into change management, into changing organizations and changing the internal systems and procedures to be able to unlock the potential and benefit from that. From our discussion today, we're going to have a diverse view of panelists to tackle the very challenges and the very opportunities of generative AI in the enterprises. Given that the panelists have been introduced and we might have one more panelist joining us, I want to start by understanding a bit more from our panelists, and maybe Dr. Alaa, I start with you, on coming up with ideas for what are some of the use cases that are we seeing in the generative AI space that are affecting the enterprises today. It is, I think.
Thank you for the question. The question is, repeat that question one more time.
Sure. Just wanted to understand from you, what do you see as some of the use cases and applications that are happening in real life in enterprises today when it comes to generative AI?
Absolutely. Great question. So I think if we wanted to very quickly answer that question, we first have to understand what the limitations are. And understanding what the limitations are will help us understand how enterprises can and can't use these models. So one of the biggest limitations that we constantly see, and something that the previous speaker touched on, is that these models are trained based on data from user input, other humans. And so they're not trained in a definitive way, and there's no definitive logic guiding the rules for what they will generate. Meaning that you need to limit the output of these models. And that's why when you really go out in practice, I'm going to venture and say that 80% of the models in production that we see today are RAG models, because you have to confine the space of what the model can discuss. You have to put some limits, some constraints. And you know, the issue with hallucinations has been a very pervasive issue. And that's why you see chatbots being broken all the time. And so when you really want to deploy these models, you want to give the consumer a product that does not do things that are not expected of the models. And that's why I think, to answer the question very summarily, it's just RAG models.
Yeah, very good. And maybe from your perspective, if you can also tell us a bit more how you see innovations in such use cases in enterprises today, specifically in the areas you focus on, which are financial services and telco, but also other examples.
Right. Can you hear me? How much time do we have? We've seen, when talking to our clients, people talking about hundreds of use cases within the enterprise. And they would mainly fall into two categories, right? The horizontal ones, the ones that every enterprise will need and can implement, and the ones that are applicable only to verticals or to the industry within which the enterprise falls. So for the horizontal ones, we'll see applications within finance, HR, all corporate functions. they all can are overworked, can make use of these generative AI technologies. Or sometimes I'd like to also not focus on the generative part, but focus on large language models, because they understand language, and just having something that has the intellect of a high schooler and thinking about how you can use them within the enterprise can help you identify use cases. So all these departments within a company would need summarization. They would need some content creation. Imagine, for example, HR. HR, they have to constantly create job adverts. They have to create surveys. They have to evaluate the surveys. All of these things could be, if not done fully by generative AI, with these models, they can be done to 80%, 90% using these models. So automating the grunt work. That's one of the families of use cases that we see. For the verticals, so a bank, for example, needs to be able to look at the journey of or the lifetime of a client, from acquisition all the way to operations, passing through onboarding, passing through also upselling. And within every single one of these boxes, you will find many small applications. So in the way you try to find clients, you use generative AI in marketing. When you have onboarding the client, maybe you want to give them financial advice that uses generative AI as a language layer, but on top of systems that are made for advice, and so on and so forth. I asked how much time we have, because otherwise we can spend the whole 50 minutes on
Very
it.
good. I think it's great that you gave us the initial thoughts, and then we'll circulate with a couple more
Sure.
questions so that we have the time running for the full panel. Issam, I want to come back to you, and I think you're coming from NVIDIA, from the infrastructure side, from the frameworks and the platforms. Where do you see the actual demand for your services, and in which verticals, in which use cases that are deployed today?
Thank you. Do you hear me? You hear me? Okay. I think, yeah, so there is an explosion of use cases and all over the places and all the verticals. And I would say the most immediate ones, and I'm not going to cover them, are related to text-based data. And with text, you can actually try to extract a lot of intelligence in the enterprise. We at NVIDIA, we are actually more excited about what the multimodality can achieve. And coming from a scientific background where we're spending a lot of time trying to advance the frontier of science, we're extremely excited to see things like, synthetic data generation using Gen AI and LLMs in several domains, industry, design, medical, that are extremely helpful. We use those techniques internally, for example, to generate scenes and to generate scenarios to train cars in simulators for autonomous driving, for example. We are extremely excited to see that addition of generating domain-specific synthetic data sets to use them for other AI algorithms, in this particular case autonomous driving, or let's say healthcare and medical imaging, for example, where we're talking about lives, right? We're talking about things that are extremely valuable, and that aspect, which is still project in the making, right? Is extremely exciting, and we're looking forward to see that develop even further.
And you mentioned examples. Are those ones that you see the highest demand today, or can you name one or two where you see this is where real life use cases are happening the most?
You mean from generative AI use cases? It's difficult to see where is the large, let's say, demand, where does it come from? Because as you mentioned, we're the engine, right? So pretty much doesn't really matter where is your use case. It's dissected later on into a certain flow where you need to train models, when you need to have an infrastructure to have large-scale inference set up for your use case. So this is where we intervene. So the answer to your question is pretty much all the use cases are actually, let's say, great use cases for what we offer, which is the platform for GPU training and GPU inferencing.
So you're basically saying across different industries, there's specific use cases that are happening, and you're kind of abstract to this, covering all of them.
Yeah.
I want to welcome also Abhinav. Thank you, Abhinav, for coming in. Maybe to put you in the spot, if you can give us a few seconds of introduction for yourself. A question that was posed to the panel about the that you have seen in generative AI.
Makes sense. My name is Abhinav Shashank. I am the co-founder and CEO of Innovaccer. We are the healthcare intelligence cloud serving care providers and insurers like across the world at this point to really help them sort of really drive better care at lower cost and more efficiency, like per se. For us, like I think we've been building like a data infrastructure for a really long period of time, like for healthcare organizations like across the world. And I think like if you broadly looked at like AI, there has been like a lot of like applications of intelligence across the board for most enterprises. Like I think like it was business intelligence first, and like I think like big data next, and like I think it's now sort of like become like artificial intelligence. But the application set today, like in healthcare, is massive. Like we're starting to see, like I think care providers starting to think about clinical decision support like very differently. They're starting to think about how to enable doctors and people like who are not necessarily like the most like trained specialist, but like I think like at a lower tier, like in a country like India, like ASHA workers, etc. How do you like enable them with co-pilots that they can sort of like really deliver like primary like care in some way or form? The stress levels on every healthcare system in every country is like I think like pretty significant. So how do you sort of really make that possible? All of the care coordination tasks that are really happening are like another call centers, contact centers, and that automation like where things are really starting to sort of really get automated are like massive. So I think like if you go verticalized and if you think about application areas, the amount of transformation that every industry is really going to go through like is like incredibly significant. And then there are like I think like horizontal pieces where like we just discussed like 35% of like I think the code base that was really submitted like I think over the last like 6 months or so globally was like AI generated. So effectively we are seeing like developers getting like more effective, like marketers getting more effective, salespeople getting more effective, and like I think the day-to-day like I think running of the business like as well. So I think we are going to see like a lot more like profitable companies hopefully like as a resultant of that in the near term. But also like I think it's something that if as a business leader you're not thinking about application areas of AI in your core system, and your competitor is like you're like just going to get blown away like from that perspective. So I think like from an application perspective, both from a business leader perspective and like as an entrepreneur serving like the healthcare industry, the applications are just mind-bogglingly large, and like we are very excited about like seeing what the potential of this is over the next 5 to 10 years.
Very good. Thank you very much. I'll come back to you around also the generation of data in the healthcare sector. There are a couple of questions that would be interesting to touch upon. But Dr. Alaa, I just wanted to touch upon some of the discussions we'd had on the side originally around some of the challenges and limitations for deploying AI use cases, whether it comes from ethical biases, from fairness, from people trying to game the system in places where it's more automated. Can you give us some examples or some real-life examples about how these things can manifest themselves?
Yeah, sure. Thank you for that question. I guess one of more recent examples that's occurred is that in New York City, under the Eric Adams administration, they released an AI chatbot that was supposed to help
today and enterprises from adopting that technology at scale.
That's a great question. I can answer it from our perspective because we believe that the entry point to control or to build your own models, even though despite that, the fact that when you see it or when you use it, it seems extremely easy and simple. The core problem is an infrastructure problem, and the access for that infrastructure is becoming more and more difficult for many reasons. Most of them are technical, but others are not. What we're seeing is not only the access to the infrastructure is a challenge, how to use that infrastructure is the second one, and the third one, how to scale your problem, is I would say, the major problem. And this is pretty much where we spend most of our time, how to demystify those three problems, make sure that we integrate them all together, bring in the infrastructure, bring some blueprints and reference architectures so people don't have to spend a lot of time to choose what do they want to do. Just come up with an opinionated choice, build a middle layer to use that infrastructure based on that opinionated choice, and then give the building blocks for pretty much all levels of enterprises so that they can compose and hopefully build their own models or tune some state-of-the-art ones. I probably say it in a very easy way, but believe me, it's a complex problem. It's a complex problem, and also less and less people will specialize on solving that problem, and that's pretty much why NVIDIA is, quote unquote, is important today, because we chose to tackle that complex problem and be expert on it.
You want to comment on this?
Yeah, actually, I wanted to ask a follow-up question, and I apologize if this is a naive question, but you work for NVIDIA. I was under the impression that scaling would be simply adding more GPUs to the cluster.
Yeah, see, that's exactly what I'm saying. Is like the impression is quite. I mean, everything is so demystified that we think it's simple. If you take a model and then you want to scale it, whether from a data perspective or from a weights perspective, it's not a linear problem. It's an utterly non-linear problem where you're adding, let's say, you're adding more components to your model to converge in a different way. So pretty much if you double the size, your problem is not going to converge linearly with respect to what you actually built in the first place. And that creates multiple problems from the mathematical perspective, but also from the infrastructure perspective, right? Not because you have twice the size, you will run twice faster, right? That's definitely not the case. So that's why scaling is really a problem because it's simply not linear.
Abdelali, what's your view on this? I think you wanted to comment on the technical hurdles as well.
Yes, there are many technical hurdles, but some are self-imposed and some are naturally there. I can join the colleagues here in reiterating the complexity of some of these problems. Data is one of them. So many enterprises have been going through a data transformation since 2015. That transformation is not complete, and if the data is not clean, then there are many use cases that will not be viable for your enterprise. But sometimes that's the reason, sometimes that's the excuse, because there are other use cases that you can implement even before your data is perfect. When it comes to scaling, you can take, let's assume you're trying to build a knowledge assistant. You take your data and you want to expose it through a chat interface. Do you now want to expose all of your data, which could add up to multiple terabytes or petabytes under one assistant, or do you want to have multiple assistants? And many enterprises start a bit too big, and they just want to have that one entry point to everything, instead of dreaming big and starting small, right? Third, there is the natural problem with these models, is that they hallucinate. Many companies just go out there and look on GitHub and say, oh, there is this free code that I can just take and implement without, putting the right guardrails by, working with, Oracle, working with NVIDIA, working with other companies in consulting companies as well, to identify where the risks are and what the right guardrails for those companies are. So there are indeed many technical problems, but that's often also an excuse not to make progress.
Very good, thank you. And Abhinav, earlier in the panel we spoke about the 10-20-70 thinking, which is 10% is needed for the data, 20% on the models, but 70% is on the people and process. And you work in a sector where there's a significant potential for Gen AI in the healthcare sector, but it's also one of the sectors where the adoption of technology by the doctors and others might be on the lower side. How do you kind of bridge the gap between the people that are going to be using that technology and the trust they have versus what you're trying to achieve?
like I think my general view is with any technology, right? Like I think if you can make it simple enough for people to use, people will use it, right? Like I think a lot of things that came like in the 10-year sort of like period where we went from like on-premise to cloud, I don't think there was a meaningful difference that you were able to create for doctors, whether they were like on a cloud-enabled system or whether they were on an on-premise sort of like system. And so yes, technology sort of like, I think like adoption of technology therefore sort of like lagged in that period. But it was generally sort of like driven by the fact that there was not necessarily like a meaningful use of like cloud that you could have sort of really driven in the space. Now, generative AI and AI is sort of very, very different, right? Like because healthcare is about science. Like you have like care pathways, like if X happens, like you want to do Y, and like adoption of those care pathways is what like everyone wants. Today there is huge variability. Like everyone wants to go to the best cardiac surgeon like in the country if they had a heart problem. Like everyone wants to basically go to like I think the best doctor for X and like Y per se. Like what does that really mean? Like all of like I think everyone was supposed to do exactly like the same thing because it is a science and it's not supposed to be art, right? Like and so like reducing variability in how things are going to get delivered, whether that's in healthcare or for your consumer experience or for like anything from that perspective is a huge value add for like AI. And now basically you've gotten to this stage where it's simple enough for developers to bring it into like workflows and change things very meaningfully for the user. It's happening like I think like across the board. Like we're seeing like provider co-pilots, we are seeing care management and preventative care co-pilots, we are seeing like patient access co-pilots, we are seeing nursing co-pilots, and I would make the bet that healthcare is probably going to be the fastest adopter of like AI than like the other way that it happened like in the last like 10 years, where cloud did, because it did not provide like a meaningful sort of like I think advantage, people did not really adopt it. But the amount of change that you can sort of really drive like because of AI, like in how care is delivered, the fastest adopting industry for AI is probably going to be healthcare.
Very good, and I just want to follow up on one of the aspects with a bit more, let's say, philosophical question, right? So I think you're mentioning this is going to be one of the fastest growing or fastest adoption of Gen AI technology and AI in general. There are a number of things that come together with adopting technology. While productivity can increase, accuracy can increase, all of that, consistency is also a key factor. There's other aspects of, say, of trust in the care providers, or in terms of identity of the care providers that are providing that, whether they're coming from their own experience or from the models and so on. So this is more soft elements. Do you see any resistance happening there for the adoption perspective, or what do you see?
I think it's an evolution like question, right? Like I think people are going to adopt it for variety of use cases over a period of time. Like my like big thing is the next $1 trillion company like that gets created is going to be in the intersection of bio plus tech. Right, like how do you sort of really bring like a lot of like data science capabilities and like the healthcare knowledge together and really drive like better like healthcare outcomes for everyone is going to be like I think the center of the next $1 trillion company. Now for doctors to really like embed it, like the first time we basically went and we've set up like massive collaboratives. Like we have 10 of the largest like health systems in like the US, like including Kaiser and Ascension and Trinity, and like a lot of them like all come together, create a collaborative on what does like safe AI practices mean. And we've got like chief medical officers of these people to really define like what are standards that we are going to like adhere on. Because one of the things that you don't really want to do is to put like unregulated like and unsupervised AI in the hands of doctors and like have them sort of like make decisions based on that. So we're setting up like frameworks. There's a lot of governance work that needs to happen, both from the government side as well as like I think the vendor side, that will need to sort of be in place over the next maybe like 3 to 5 years. But no one's asking the question that is it coming? Like it's here. Like the train left the station. Like if you're not like on it, like I think like you're missing out big time is the realization that's like across the board. And we're starting to see like I think like doctors really enjoy it. Like the NPS scores of like our products, oh my God, like this is through the roof. Like it's just so amazing to sort of like see people using words like joy. Like doctors, when you go and talk to them about any technology, like they're like, I don't want to use it, and like all of those sort of like things. And for the first time, people are using words like, I am re-experiencing the joy of care. Because I get to focus on things that I really wanted to do and not like these administrative tasks that like AI is sort of really able to help us. It's going to evolve from there. Like it's going to get into more clinical use cases. It's going to get into like surgical planning, like and like a lot of those sort of like things. But like I don't think it's a real question at this point whether it's going to happen or not.
Very good. I want to kind of shift themes into the future of this technology, and maybe we go in a round-robin fashion, and I start from you in a sense. How would the future of this technology look like? Maybe from your perspective, where you work today in a New York City Council, what are some of the applications that you're looking for? What is the future of what you're trying to achieve? But also more broadly, where do you see this going in the future?
Okay, so great question. And to answer this in a broader fashion, I'm going to take 1 minute to go through a quick recap of the history of the evolution of modern AI. So 1997, we had LSTMs, long short-term memory neural networks. And those were able to look at the previous words in a sequence of words and then predict the next word. And then fast forward 2015, you get the attention mechanism, which was able to look at the previous words in a sequence as it's trying to predict the next word and remember and assign an importance to those words. And then you got transformer models, which was able to just do it a lot faster by simultaneously processing all the previous words in the sequence. And my point being here that I'd say the LSTMs in 1997 were like a really big change in the architecture of the neural networks. And since that occurred, we just made smaller changes that increased the efficiency in which we could train the models. And then in 2020, I think the biggest and most recent huge scientific realization was that there's a power law scaling between compute, data, and number of weights parameters, the size of the model, and the loss of the model, the performance of the model. So basically, scientists realized that we could just throw more electricity at these things and make them bigger and throw more data at them, and they're just gonna start doing better and better. And that's how we hit 2022, where we got these models that were responding in such a human fashion all of a sudden. And it seemed like magic, but it wasn't magic. And it was the same technology in a large aspect that we had back in 97. And so the reason I'm saying this is to highlight the point that the technology actually, I don't believe it's evolving that fast. It's still unable to think in the sense that humans define thought. And therefore, I am not very excited about the future, given the current trajectory that I see. I know a lot of people may disagree, but I don't think we're gonna get over the hurdle of it's just putting words together and it's not actually thinking. That's gonna take like some sort of renaissance in AI where we really just rethink the whole structure of these models and the objective functions that we're applying to them.
I guess, Abdelali, you have a different pitch maybe that you give to your clients in that sense. Do you agree? What's your comments on what has just been said?
No, I see where you're coming from. There is a risk of that, but the way I see it is more, when we say AI, it will be ambient intelligence, present everywhere, just like we see it with the Apple intelligence being presented. I also see a world where we express intent and then things happen. So you say, I want to book a trip somewhere, and there is a series of agents. There would be probably billions or trillions of these small agents specialized that work with each other on solving a problem. Some of them will be tiny and run on your machine, some of them will run on servers, and some of them will be, maybe let's call them the mother models, that will necessitate tens of billions of investments that will be running somewhere, but they will work collaboratively to solve the problem that we humans have, or the challenge, or maybe if you want to generate something. That's how I see it. So billions and billions of smaller models are available to small agents or big agents there to solve our problems.
This is an AI and Web3 festival, right? I've recently seen now the simulation of civilization that they've done recently, where a few thousand agents were put together with human-like behaviors to study that simulation. I think that's a fascinating way in which we're starting to see some convergence of the agents and the technologies and see how that goes to the future. But I guess there will always be both sides. Maybe just moving back to you, Issam, as we look into the future, again, more from an infrastructure perspective.
Put it closer to you.
How the future of infrastructure would look like for this technology going forward. Models, people speak about infusion of application-specific computing, speak about future of quantum computing and others. How do you see it from your perspective? Will this continue to scale as is, or will we see more hybrid architectures in the future?
I think we're facing the same uncertainties, right? I will be lying to you if I'll say, hey, we're going to scale and we're going to stay where we are. I think, this type of algorithm is the new driver of innovation for silicon, from the silicon to the infrastructure, right? So that's the new driver. You will see all sorts of type of approaches. We already see the shift in terms of like the heavy lifting, right, of the big infrastructures. Servers are getting denser and denser. Racks are getting taller. Clusters are getting, denser, and then the cooling technologies are changing. The space is changing. The way how to manage these infrastructure are changing. One more time, they're becoming more and more complex. So I think at least in the near future, we're gonna see that trend continuing. We're already releasing things that are insane when you just put a power label or a compute label on an infrastructure. 5 years ago, it would be unimaginable to mention those names on the stage or these numbers on the stage. Today, it's mainstream. And and I think that's a trend that is going to continue.
Fantastic. And Abhinav, I'm aware of the time. I want to finish with you with the final question. You're in the healthcare industry. There's been a mixed picture, been patented now. Give us some hope for the future. How do you see the future of this technology in the context of healthcare, but also more broadly?
Listen, like I have never been more excited about technology than the last 2 years in my life. It's like magic. Like, what are we talking about?
Yeah.
Like, I think this is just incredible progress that we've sort of made. I think web was an incredible progress that we made 20 years ago. The art of possible of connecting people globally basically changed, and Amazon came out of it, and Facebook came out of it, and a ton of stuff basically came out of it. And therefore the transformation that we've sort of seen in the last decade or so, because of the application of web technologies has been I think massive. This is an order of magnitude more. The kind of change that we are basically going to see in everything around us, whether this, how we sort of like, I think like work, whether how we sort of like educate like our kids, like what are they sort of really thinking about, whether like I think it's about like doctors really caring about like patients. A lot of those things are just basically going to change so dramatically over the next like 5 to 10 years. I don't think like we are able to sort of like imagine the quantum change that we are going to see over a 10-year period. Bill Gates says this like I think like really well, like when he says that you always overestimate what you're going to do like in the next 1 year, and always underestimate what you're going to see like change in 10. And I think like the impact of this technology over the next decade is just like meaningfully transformational. Like now how people sort of really go about it, how do they deploy it, like I think in their enterprises, a lot of those things are to be still figured out. I think like everyone is taking bets, like setting up their infrastructures. I don't know whether it's sort of like I think like going to be relevant or not, but like one thing is for certain, that over a 5-year period we are going to be living in a very, very different sort of like world. And I think like all of this scare around the fact that it's going to take away our jobs, it's going to evolve. Like I think like our cars came in, like didn't mean like all of us are unemployed. Like I don't think like AI is sort of like I think like going to come in and all of us are going to be unemployed either. We are going to evolve. There is a lot of like I think policy level thinking that needs to happen. There is a lot of like organizational thinking that needs to happen. But I think we are living in the most exciting time that the last 10 decades of like, or like last 3 or 4 generations have sort of like lived in. So like I would just close with that this is like, we can all be Iron Man at some point, like pretty soon. So, which is like pretty cool.
Very exciting and dynamic times indeed. I want to thank you and the rest of the panelists for participation today, and thank you the audience for attending as well. Thank you and have a great day.
Thank you.